Okay, C. Lindelof videos, AP Calculus, another ladder problem from related rates. Thought I'd do this one. It says a 20-foot long ladder leans against a vertical building. If the bottom of the ladder slides away from the building horizontally at a rate of 2 feet per second, then we're asked to answer this question. How fast is the ladder sliding down the building when the top of the ladder is 12 feet? So I'm going to start looking at this. This vertical and horizontal tells me that I have a triangle, so I'm going to draw this as the vertical side of that building. Let this be the ground, and let the ground be flat, if you don't mind. To that, we're going to apply a ladder, so let this be our ladder right here. I'm going to just give these little, that's my ladder. Don't say anything, it's my ladder. We're told some stuff. In our scenario, it's 12 feet above the ground, so this point right here is 12 feet above the ground. We know that the ladder is 20 feet long. And we also know that it's sliding horizontally at a rate of 2 feet per second. Well, horizontally is on x, so we're going to say that dx dt, the rate that x is changing given time, is equal to 2. From here, there's a lot of ways that we can go. What I think I'm going to do here, though, is this. Anticipating what's coming next, I am going to finish this work on this triangle. So I'm going to just do this. I'm going to get 12 squared plus x squared is equal to 20 squared. If I go through all of that math, and you should go through all that math, I'm going to get that x squared is equal to 256, and then x is equal to 16. This is, in fact, a Pythagorean triplet. So there's that Pythagorean triplet right there. Now what I'm going to do is the other thing that we need to do in related rates, which is come up with an equation that encompasses our problem. And the equation that I have is x squared plus y squared is equal to h squared, where h is this, the hypotenuse of this right triangle. So I'm going to go ahead and do the other thing that is always done in related rates, and that is take d dt of the equation that we come up with. And d dt of x squared is 2x dx dt. Remember, we're not, some people get turned around on this because they're like, no, we can differentiate this. We can take d dx of this and get something cleaner. But we're not taking d dx, we're taking d dt. Therefore, we have to treat this as if it was chain rule, so we have to take the derivative of the inside with regard to t, and that's dx dt plus 2y dy dt is equal to 2h dh dt. I don't know if you can see this yet, but dh dt is how much? What is the rate of change? What is the rate of change of the ladder as time goes by? Because this height value, remember, this is a ladder. This purple thing is a fixed quantity, and therefore its derivative is 0. Right? Its derivative is 0. So this whole thing goes to 0, and that's going to help a lot. Remember why that happened. We took the derivative of the fixed quantity. This fixed height of the ladder does not change. I'm sorry, I don't want to say the fixed height of the ladder, the fixed length of the ladder, because it is a 20-foot long ladder. This height changes, this x changes as this thing goes down, the ladder gets pushed up, but nonetheless, this will always be 20 feet the whole time. So something to think about in the ladder problem. Having said all that, we know some stuff here. So let's fill in the stuff that we know. This is x, so x is equal to this. This is y, so y is equal to this. This is h, but we don't need it, so this is what I'm going to say. I'm going to say that 2 times x is 16. I also know that dx dt was given to us as 2, plus 2 times y, the y value is 12. dy dt is what we're interested in, isn't it? This says, how fast is the ladder sliding down? So that's dy dt, right? That's dy dt, change in height, it's sliding down, is equal to 0. So, do all this math, this crap together goes to 64. This crap together goes to 24 dy dt. Is equal to 0. I'm going to start moving stuff around because I want to isolate my dy dt. So what I'm going to do is I'm going to add negative 64 to both sides. We'll get 24 dy dt is equal to negative 64, right? Because we subtracted that from both sides. Now we'll divide by 24, and we'll get dy dt is equal to negative 64 over 24. A little simplifying here. 8 goes into 64 8 times, so negative 8. 8 goes into 24 3 times. Remember, this is change in height, so it's feet, because that was the measure that we used, and it's feet, and this thing is falling 8 feet per second. All right? So this is another example of the ladder problem. Why do we always talk about the ladder problem? Two really good reasons. One, that every calculus professor in the world seems to love this problem. And two, and more importantly for many of you, is the fact that the ladder problem in one shape or another shows up on the AP exam every year. Not always on free response, sometimes on free response, but always somewhere, and definitely somewhere in multiple choice. So I hope this is helpful. If you haven't already subscribed, please do. And your comments are always welcome. Thanks, guys.